Alright, so in this video I'm going to go over how to analyze a set of data that you collected in a physics experiment, and this is an experiment that leads to a non-linear relationship, as you'll see in year 12. So this is a set of data that was collected in an experiment where a trolley was rolled down an incline, so a bit of a slope, and what we changed was how far we allowed it to roll, and what we measured was the final speed that it reached. And this experiment was the speed was measured using a light gate, which gave a very accurate or very precise value for the speed. The speeds were recorded 3 times for each distance, so that we could take an average to reduce the random uncertainty in or random error in the experiment. So what I'm going to do first is just add an average here, and to compute the average for each of these rows, I'm just going to write equals average, an open bracket, and then highlight the 3 cells that I want to average. So that's now the average of the top row, and you can see that it is, because 162, 3, and 4 should be 163. To compute the average for each of the following rows, I'll just left click on the little blue box in the corner and drag it down to autocomplete. Okay, and now you can see that these are the averages for each row. We should really keep it to 3 significant figures because that's what our values were measured to. So I'm just going to change it to 3 significant figures by using these decrease and increase decimal places buttons. And you'll see that this one was 0.420. It had reduced it automatically, the spreadsheet. And the distances, they were measured with a millimeter ruler, so we should really have that to the correct precision, which is 3 decimal places as well. So now all of this data is correct. I'm just going to do a few things to neaten up the table. So I'm going to add another row above here, insert one above, and then I'll call all of this speed so I don't have to have so much writing. So this is the final speed reached by trolley, and that's in meters per second. And then I will center that, and I will merge these ones to make it a little bit neater and just align it in the middle. And then now I don't need all these units here because I've got it in the heading up above. So I'll just fix that as well. Okay, and then I'll highlight my whole table, add some borders, and just to make it consistent, I'll center everything. So there now is a completed table of my raw data. So I'll copy that into my report. So I've set up a little report here. This is just going through the data analysis part. So this is assuming you've already done all the planning part. So raw data table, and I'll change that to a heading, maybe that kind of heading. And I'll paste it in, and I'll paste it unlinked just in case I accidentally make some changes to my table in the spreadsheet. Okay. Now what I want to do is plot a graph of the average final speed on the vertical axis against the distance traveled. So now that I've worked out the averages, I don't really need these 3 columns, so I'm just going to hide them so they don't get in the way. And then I'm going to highlight all the numbers that I want in my graph and go Insert Chart. So there's a plot of my raw data graph, of my raw data. And it looks pretty good. There are a few things that I want to change here just so it's labeled correctly, and I want to have 0 as my first point on the horizontal axis. So I'll click on Customize, choose Chart and Axis Titles, and I'll first choose chart title here, and rather than just average, I'll call it average final speed. Whoops. In meters per second versus distance. Okay. And then I'll choose the vertical axis title because that just says average at the moment. I'll say average final speed in meters per second. So now that the labels are all correct, I just want to change it so that 0 is included. And in fact, I also want to change it so that it has crosses rather than blobs as my points, because it's easier to see where the center is. And I then want to click on the horizontal axis and tell it that the minimum value should be 0. And now my graph here looks pretty good. So I'll take that graph, Control C to copy, and I'll write raw data graph. And I'll paste that unlinked. And here now, this graph, the reason why we plotted this graph is just so we can see what type of relationship it is. And this looks kind of like a sideways parabola. We probably already suspected that it would be a square root relationship because we would have been given the relationship in the task sheet. So we'll just say here, this looks like a square root relationship. I will therefore take the square root of the distance to linearize my data. So if whatever relationship we identify in the graph, that's the transformation that we need to do to our independent variable that's plotted on the x-axis. Okay, and then I'll hit Control Enter to create a new page, and now we'll call this the transformed data table. Alright, so going back to this place here, I'm going to get rid of this graph now because I don't need it. In fact, I'll just drag it out the way just in case I want to make some changes later. And then I'm going to create a new data table here, which is going to be square root of distance, and that's measured in square root meters. Excel doesn't have a nice quick way to enter the square root symbol, so I'll just leave it as that. And then I'll merge those two cells, and then I'll wrap text just so that it fits in, which it doesn't quite, so I'm going to widen the cell a little bit. And then I'll do the same with this one, and this is going to be the final speed reached, and that's in meters per second. Oops, and then I'll merge those two. There we go. So the square root of the distance, we just punch equals, and then we write the function sqrt, which is how Google Sheets does the square root. And then we'll click on the thing we want to square root, which is this 0.1 here. That's our first distance value, and then we'll hit enter. That's now worked out what the square root is in this. And I will click on this little square again and autocomplete, so it works out the square root for each of those values below. I then want things to the same precision that I measured it, so I'm going to reduce the decimal places until I have just 3 significant figures, which I had in my original data. The final speed reached is unchanged. This is going to be the same value that I measured before, which is this. And then I'll autocomplete, and it'll copy that number from each of those boxes. Highlight the whole table, let's add some of these borders, and let's center all the data. Okay, so that's now going to be the transformed data. I've got the correct transformed unit here for the square root of distance, and all of my data is there. I'll copy that and put that into here. And I'll paste that unlinked. And just to show that I understand what I did, I'm going to include a sample calculation here. So to determine the square root of the distance, I did the following for the first value of the distance. And then I'm going to go insert equation, and I'm going to go you can insert various things. So if you want a square root, you can click it there, but you can also there are some shortcuts. So /sqrt gives you a square root automatically. So square root d, and then equals square root 0.100 meters, which is equal to 0.316 square root meters. Okay, so that just shows anyone reading my report how I got these values. Okay, the next thing we want is our linearized graph. And to get the linearized graph, we just do this. So we have the the new data here. We'll just highlight the numbers that we want to use and choose once again Insert Chart. And this now is our linearized data, and it looks like quite a good straight line, so that's promising. Just need to do a couple of things once again just to format this correctly. We want to change to crosses instead of blobs. We want to add a trend line, which is a line of best fit for this data. And we want to use equation in the label, and that will give us our gradient here and our y-intercept so that we can write our equation. And the last thing we want to do is make sure 0 is included. So I'll get rid of the series thing, and I'll choose horizontal axis, and I'll choose minimum value 0. And that now shows us that the y-intercept is very close to 0 here. Okay, get rid of that. And this is our transformed graph. So I'll copy that over into our report. Okay, so now what remains is to write a brief conclusion, including our equation here. So equation, or in fact I'll write conclusion. The relationship between the final speed reached by the trolley in meters per second and the distance and the square root of the distance is linear. So note that I've written here square root of the distance. We can show that we understand by saying this means that there is a square root relationship between the final speed reached and the distance traveled. Okay, the equation for the relationship, let's get that now. So once again I'll insert and I'll choose equation here. And so we want it to be like y equals mx plus c, except for y and x are going to be final speed and square root of distance. So we can say v subscript f equals, and you can do the subscripts and things up here. So you can choose subscript here, but you can also just go underscore and we'll change it to subscript. So Vf is equal to, and the gradient here was 0.508. We can read that off our label for the line. 0.508, and then times, so I'll write / times spacebar, and then we want the square root of the distance. And then plus our y-intercept, but our y-intercept was negative, and this e minus 3 means times 10 to the minus 3, so we'll write here minus 0.00357. So that's the equation for our relationship from our graph. So maybe we'll write that. The equation for the relationship is, and this then takes us to the end of the data analysis part of the report. So what remains to do is to sort of comment on how that compares to theory, and then to evaluate your methods and the experiment itself. So just to recap, what we did first was we neatened up our table and computed the averages. We then plotted a raw data graph, which allowed us to identify the type of relationship that we had found between the independent and dependent variables. We stated what that relationship was. We then took the appropriate steps to transform the independent variable, which in this case was a square root, and we also transformed our independent variable unit. And I showed a sample calculation of how I did that. And then we plotted a graph of our transformed, our dependent variable against our transformed independent variable. and we included a trend line along with a label of the equation. We then wrote our conclusion, and we stated the final equation with our dependent and independent, transformed independent variable in it instead of y and x.